Good evening, students. Today I am going to explain the principle of feedback. Before going to the session, let me recall the concepts which had been discussed earlier. In the last class, I had discussed about feedback, what is feedback, and what are the types of feedback, and gain of negative feedback. That means derivative part, where AF is equal to A by 1 plus A beta was derived in the last session. Was explained in the last session. Now I am going to explain the principle of feedback and types of feedback topologies, so that students just recollect the concept of principle of feedback once, so that in the last class I have explained what are the components present in the feedback amplifier. Total setup consists of majorly four elements. First one is basic amplifier, second one is feedback network, next sampling network, mixing network. All these elements constitute an amplifier section. The total setup is called as feedback amplifier. Student, all of you look at this. It is nothing but a basic amplifier section with a gain of A. A is the gain. For this amplifier section, the input can be either voltage or current, and it is going to produce an output voltage or current. Hence, in order to revert the output to the input side, we are going to use this feedback network. That means it is going to take the output, right, with the help of sampling network, and it is going to generate some output, and it is going to be reverted to the input end, and that output generated by the feedback is going to be mixed with the general input and forms the total input for the amplifier section. It is very clear. The output from the amplifier is fed as input for the feedback, and the output from the feedback is fed as one of the input for the mixing network, whereas the other input is the general input or source input. Hence these two are going to be clubbed. As we are using negative feedback, both are out of phase. That means this input will be out of phase with this feedback output signal, right? So that the amount of voltage produced or current produced is going to be decreased, right? Are you getting? Right. So out of phase means the voltage produced by the feedback network is going to be reducing the input quantity Vi. Okay, right. So these are the four basic elements: basic amplifier, sampling network. Sampling network is nothing but the extraction part of the output quantity. So is going to be done by this sampling network. Mixing network, it is nothing but a summer network, right? Similar to adder subtractor element, so that you are going to have a mixing of the general input and the output from the feedback, right? Feedback amplifier is one in which a part of output of an amplifier is fed back to the input, right? It consists of four basic elements like amplifier with a gain of A, feedback network, sampling network, and mixing network, right? In general, students, the feedback network is going to be built by passive elements like resistors, capacitors, and inductors. I will show you this circuit of the appropriate feedback amplifiers, so that you can easily identify what are the elements present in the feedback network, right? Students, before going to the topology, I am going to explain you what are the types of feedback amplifiers available. You are going to have four types of feedback amplifiers. you are going to have four types of feedback amplifiers: voltage series feedback amplifier, current series feedback amplifier, current shunt feedback amplifier, and voltage shunt feedback amplifier. All of you look at this. The first term here, refers to the sample that is going to be extracted from the output end, right? So that I am going to extract voltage at the output. Students, please make it clear. I am going to repeat the first word in every feedback amplifier, please. You can identify either voltage or current, right? The first word indicates what is the sample you are going to extract. If it is of voltage, you're going to extract voltage from the output end. If it is of current, you're going to extract current from the output end. Right. So the first thing is you are going to identify what is the entity that you are going to extract from the output side. Here it is voltage, here it is current, here it is current again, and here it is voltage. So that, next, coming to the second term. The second term indicates how we are going to mix the extracted one, right? Here it indicates series. Here it indicates series. That means whatever may be the output generated by the feedback is going to be mixed in series. Here also, whatever may be the output generated by the feedback, it's going to be mixed in series. Here shunt, that means parallel. Here shunt, that means parallel, right? So the first word indicate what is the sample you are going to extract at the output end, and how we are going to mix at the input side in format of series. Hence voltage is the component extract from the output, right? And the output from the feedback is going to be mixed with the input in format of series. Hence it is called as voltage series feedback amplifier. If it is of current series, current is the sample that is going to be extracted from the output end, and the output of the feedback is going to be mixed in series with the input end at the input side. Coming to this, current is the sample extracted at the output end, and the output of the feedback is going to be mixed in shunt, that means parallel with the input end. Coming to this, voltage is the sample that is going to be extracted from the output end, and voltage is the sample that is going to be extracted at the output end and mixed with the input in format of shunt, that means parallel, right? So you can have how it is going to be, right? Students, look at this voltage series. Students, please do remember the second word especially, right? Students, please do remember the second word. If you are going to have series, if you are going to have series as the second word, you are going to take the voltage source, right, at the input side. I am repeating, if you are going to have series as the second word, please take the voltage source at the input side. If you are having shunt in the second word, please take the current source at the input side. For these two entities, or for these two amplifiers, Vs is taken at the input end. For these two amplifiers, Is is taken at the input end, right? As students, please see here, voltage series. Series is the second word, so I have to take Vs as the input source, right? Fine. So that here the first word is voltage, so that I have to take the voltage quantity from the output side, right? So if you see here, let me take the basic amplifier. Let me draw the circuit. Let me draw the circuit. Let me draw a fresh circuit. Let me take an amplifier. This is your amplifier. Let me take a feedback element. This is your feedback element, and I'm going to explain about the concept of voltage series. Here I'm going to give the input. input section, right? What is the source I have to take? Vs, right? Voltage source. Let me assume it as Vs. Because voltage series is the second word. Series, if it is of series, please take input as voltage source, right? This is voltage series feedback amplifier. Right. So that I am going to take the output, and also in the output I am going to take load also, load resistor, right? Let me treat it as resistor, load resistor, right? Fine. And students, if you see the first word, voltage is going to be sampled, right? So that from the output, and I have to take the voltage quantity. If I take the voltage, whatever may be the voltage developed across RL is V naught, let it be V naught, V naught. So I have to take the same V naught as input for this feedback. I have to take the same V naught. That means I have to make a parallel path. So the same thing, that means the positive end is connected to positive of the feedback. That means there will be no terminals. For your convenience, I am taking it as terminals. Let me treat it as positive and let me treat it as negative. So positive to positive end. So I am going to connect it to here. Positive, negative, all from negative to negative. This. If you observe, whatever may be the voltage developed is going to be given as input for the feedback element. This is your feedback element and this is your amplifier section, right? So whatever may be the output voltage developed, voltage is going to be sampled or taken from the output end and given as input for the feedback. Hence the first term is satisfied. Voltage is going to be sampled and output from the feedback has to be clubbed in series, right? So that in series the connection will be like this. The connection will be like this. Hence it makes voltage is the element that has been taken from the output end and it is going to be clubbed so that the output is also in voltage format and it is going to be clubbed with a Vs. Right students, in the next lecture I am going to explain in detail about the this topologies or feedback amplifier construction. So how you are going to take the series or shunt at the input, or how you are going to take the series or shunt at the output part, right? Thank you.